In Antarctica, few animals can survive the howling winds and frigid temperatures up on the land blanketed by snow. But here in the Southern Ocean, under the serene, cool blue ice cover, Antarctica is teeming with life. In these frigid waters live creatures that would feel right at home in a 1950s monster movie. Giant sea spiders, jellyfish, anemones, and sea urchins.
They're living in water that's so cold that you can't even put your hand in it for 5 seconds without feeling extraordinary pain. It's just like right above the freezing point of seawater. It's so cold.
Today, the ability of these animals to survive in sub-freezing waters is being tested by a new threat, ocean acidification.
The Antarctic and the Arctic are thought to be possibly some of the more vulnerable marine ecosystems to climate change. And they might be the first in time to really have acidic waters meet the organisms that live there.
What's making the oceans more acidic? Scientists blame the carbon dioxide created by the burning of fossil fuels. The CO2 goes into the atmosphere, but as much as 30% is then absorbed by the oceans. The more carbon dioxide, the higher the acidity. Initially, scientists welcomed this absorption of carbon dioxide by the oceans because they believed it would reduce CO2 concentrations in the atmosphere. But as the oceans take in carbon dioxide, now the question for scientists is how much is too much?
We knew that we were burning things to make energy, and that carbon dioxide, some of it was ending up in the oceans. And for many people, that was seen as a good thing. What we're recognizing is that there are changes in the composition in the oceans.
In the last 150 years, as CO2 has increased in the atmosphere, the pH of ocean surface waters has dropped by around 0.1 pH unit. That's a 26% increase in ocean acidity. And the Intergovernmental Panel on Climate Change predicts an additional drop of 0.2 to 0.3 pH units by the end of the century. That's a 100 to 150% increase in ocean acidity since before the Industrial Revolution. As the ocean becomes more acidic, it makes it harder for marine animals that build their shells out of calcium carbonate, like corals and oysters. At the University of California, Santa Barbara, scientists are studying the effects of higher CO2 on sea urchins.
We mix the carbon dioxide into our seawater tanks to mimic future high CO2 oceans, levels that we thought we'd go to in 100 years or something. And we do start to see effects at those high numbers in terms of slowing down their growth. They are a little bit smaller at any time in development. And also there's some effects on fertilization, we think, when water gets really acidic.
Not far off the coast of UC Santa Barbara, ocean acidification could have a direct impact on people who make their living harvesting sea urchins.
My name's Bruce Steele. I'm a commercial sea urchin diver. I work at the Channel Islands, which are right here off the coast.
The boom for sea urchin sushi started with the Japanese back in the 1980s. Now the uni crop brings the state of California over $100 million a year and provides essential jobs to hundreds of divers and processors. But the changes to ocean chemistry have them worried.
The problems that we're seeing with animals like sea urchins or oysters are kind of a harbinger of problems that might be going on in the open ocean.
Two recent events clearly show that ocean acidification has already arrived on western shores and could have a direct impact on the seafood we eat. In 2007, Science magazine reported that surface water in places along the California coast was already more acidic than researchers predicted. Around the same time, news reports started trickling in from oyster hatcheries in Oregon and Washington state. Millions of larvae were dying. The culprit, ocean acidification.
It seemed that it was actually the change in the chemistry of the seawater that was killing the larvae.
The massive die-off alarmed both the seafood industry and scientists. In California, they joined forces to do something about it. They're sharing data and standardizing water measurements to determine which species are most vulnerable.
There's a crew of us, the oystermen, the fishermen themselves, scientists and other people in the community are getting together and kind of asking, how can we work together to address some of these growing economic issues?
Back in Antarctica, where scientists predict acidic conditions will be felt first, the options for Gretchen Hoffmann's sea urchins are quickly dwindling.
It's kind of like a double-edged sword. They've learned to live in a really cold environment that stays cold all the time, and then here comes climate change, so the ocean's going to warm and the pH is going to change. And where are you going to go? Where can you migrate to that's colder if you're an Antarctic urchin? Well, nowhere, actually.
Since the beginning of planet Earth, animals have adapted to changing conditions. But adaptation can take thousands, even hundreds of thousands of years. Now, with millions of tons of carbon dioxide going into the oceans every day, can the creatures of the sea change quickly enough to survive in the changing oceans?